try to prove this inequality, which looks like it might be fairly sharp. By sharp, I mean the left-hand side is not much smaller than the right-hand side. Now, we'll start out with an observation that makes it more clear. 18 squared is equal to 324, right? So that means that this would be less than 18, right? The square root of a number less than 324 would have to be less than 18. And again, that's clear just by taking the square roots of both sides of this. All right, now this is quite a bit greater than 18 since 342 is bigger than 324. So this is greater than 18 by a more substantial amount. All right, and this is just a little bit underneath. This is 323, so this is less than 18, right? And the differences are varying, of course. So now notice that 3 times 18 is 54, and this is kind of crude right here, but hopefully it'll whet your appetite. That proving this, it should be pretty close. This left-hand side shouldn't be much less than 54. Now, it turns out that the Cauchy-Schwarz inequality is ready-made for this, believe it or not. And it's ready-made once you see that 306 factors into 17 times 18, 342 factors into 18 times 19, and then 323 factors into 19 times 17. Now, what you do right here, folks, is you just kind of make the numbskull assumptions here. We would want to look at this as far as the left-hand side goes. This would, the square root of 17 would be a sub 1, square root of 18 would be b sub 1. Now, for this particular problem, our n is equal to 3, right? N equals to 3. No doubt about that. We have 3 sum n's over here. And of course, this would be a sub 2, b sub 2 right here. And this would be a sub 3, b sub 3. Now, also there's a cyclical character to this. If you like using that word, you know how everything's at the tail end. Here you have root 18, root 18's at the front, root 19 at the end, root 19 in the front, and then the root 17 comes back. So this is actually sort of cyclical, not that you really have to make that observation, but it's cyclical in some sense. Okay, now the Cauchy-Schwarz doesn't care. So again, the original problem statement, this is the left-hand side of the original problem statement right here. Let's see, can I keep it on the same screen? Yes, okay. And so what we do is we make the appropriate assignments as we've already done, and then we just apply the Cauchy-Schwarz inequality. And I went ahead and wrote this step. We could have just put 17 in, but I wanted you to see that I'm doing the squares of the a sub i's right here, and I'm doing the squares of the b sub i's right here. It's just totally, it lines up perfectly with the Cauchy-Schwarz inequality statement. By the way, folks, this is often called Cauchy-Schwarz. This guy right here just gave Cauchy the credit, but there's a guy named Schwarz apparently that had something to do with the development of the inequality. But anyway, it all works out very nicely because notice that this cyclical sum n is just the same. These numbers sum up. 17 plus 18 plus 19 is the same no matter what order you do it in, right? It's the commutativity property. And so you see this would be less than or equal to the square root of something. Let me write this off to the side. The square root of x times the square root of x is certainly equal to x, right? No doubt about that, almost the definition, provided, I guess, I don't know if x has to be positive, but we'll go with that. So the square root of something times the square root of something is the something, right? And so, so this would be less than the square root of 17 plus 18 plus 19. 19 plus 18 is 37, plus 7 is 54. And y'all notice it is strictly less. You don't have to, there's conditions on the Cauchy-Schwarz. If these ratios, if a sub 1 over b sub 1 is equal to a sub 2 over b sub 2 is equal to a sub 3 over b sub 3, the equality condition occurs, but you don't even have to think that far. I'm sorry, this should be less than 54. The square root of something times the square root of something, sorry. Erase. Yeah, this is going to be less than 54. And so that actually completes the proof. Remember, we were supposed to show that this object was less than 54. And anyway, that does it, folks, for the Cauchy-Schwarz inequality. for this particular problem. I hope you enjoyed it.